Right. All guys, welcome back everybody, right? So what we have covered right, in the last classes, right? So we have seen that how to configure the IP addresses on the router side. So normally we have seen the few commands. So first of all, we have seen the modes of the router. So we have seen the user mode we have, right? Then we have seen we have a privilege mode, right? Then after that we have a config mode. So majorly this mode we have in Cisco IOS router if I talk about, right? And then after that, we have seen that if you do not do any kind of configuration, then you need to go in the configuration terminal mode, right? If you want any kind of configuration, right, then you need to jump. Come on. In global configuration, right? Then after that, we have seen that how to configure the IP addresses on the interface, right? So you just need to go on the interface 0/0. So normally you cannot jump into the interface mode directly from the user mode, not even the privilege mode. So you cannot go in the interface mode directly from here. You cannot go from here even, right? So you have to follow the hierarchy. So you have to first go in the user mode. Then from the user, you can go in the privilege mode. Then privilege, you can go in the config mode. And then you can go in the interface mode. You need to follow the hierarchy in a ascending way. But when you come to the descending order, you do have ability. If you put the end command out from here, you can directly jump in the privilege mode. If you put the control Z, right, then you get the directly come in the privilege mode. You have a ability. So you don't need to follow the hierarchy when you go in the descending order, but when you go in the ascending order, you need to follow the hierarchy for that. And on the interface, you just need to configure the command IP, the protocol IP we have. And on this protocol, we are giving that's address is 1.1.1.1/8. And then after that, we need to put the no shutdown command. Guys, please mute. Okay, so then you need to put the no shutdown command over there because by default, router interfaces are in down state. Right, and switch interface are in up state. So you need to put the no shutdown command over there, and then you can directly jump up that particular interface. So this is the way that you can configure the interface on the Cisco IOS router. If you want to put the exit command, then you can move to the privilege mode from the config mode. If you want to put the exit command on the interface mode, then you can jump to the config terminal mode if you put the exit command. And then once you go in the config terminal mode, then again you have to put the exit command. You need to go in the privilege mode. Then after that also we have seen that, right? If you want to do any kind of verification, so normally all the verification you are doing in this mode, right? But if you want to do the verification in the config terminal mode, for example, if you want to do some verification in config mode, then you need to use do keyword. For example, I want to check the show IP interface brief, this command. So this command will throw the error message. Then what you have to do, you need to use the do command on the config terminal mode. Right. After that, also we have seen, like, you can also configure the /31 address on that router interface. You cannot configure on the PC side, but you do have ability. You can configure, for example, 192.168.1.0, and I can configure like this by 254. So a network ID, right, you can configure on the router interface. At the same time, you do also have ability. You can configure the /32 address on the router. That's called as a loopback address. So you need to put the loopback, LMIS loopback, right? Loopback, any number you can give it. So I just use the loopback number 1. And as the IP address will be, for example, 1.1.1.1, or maybe 191.61.1/32. I can use it. But this /32, right? This /32 address you cannot use on the Ethernet technology. You have to only use on the loopback interface. You cannot use on the Ethernet. On the Ethernet technology, if you have a point-to-point network, right? Point-to-point means what? Only the two users are present. For example, router 1, router 2, only the two users are present. Then you can configure the /31 network over there. But if you have a broadcast mechanism like that way, router 1, you have a switch is connected over there. This is the switch router 2, then we have router 3, and then we have router 4. In that way, you cannot configure the /31, right? You have to go with the /30. The reason is that we don't have this, not /30. We can go with any other range, /30, /28, anything. But /31 you cannot go with, because only you have in a /31 you only have 2 IP addresses. But requirement is the 4 right now. So you need to go with the maybe 29, 28, anything. Because in this case, you need a broadcast ID. Okay. That's we have done yesterday, right? Now let's start the practical from the switching. So just yesterday I gave you how to configure the IP addresses, right? So that was not like a lab. So today we are going to start all the switching part. So as I mentioned that in the day 1 classes, right? So we are going to start with the switching, then routing, and then jump to the advanced lecture. So the first case is what in the switching, right? What you have to understand, the communication between the PC to PC, how the PC to PC communication is happening. So take example, I have a user 1, okay. And same way I have another user is sitting in the another side. These users are connected through the wired media, right? So I can say that this is the user connected to wired media. So I'm going to use the crossover cable, same device, right? And then I need to configure the IP address on this PC, right? So I'm saying that IP address for this guys are maybe 1.1.1.1. And the MAC will be same thing. IP will be 1.1.2. And MAC will be B. So this is the PC1 and PC2 we have. Now, so try to understand this example first of all, then I'll come to the PC. So if you remember that I gave you this example in the second day of the class as well. So there is a user, right? Yeah, that's fine. So there is a user, right? And who is sitting in the Bangalore HSR layout. Okay, and there's another user is sitting in the Delhi Lakshmi Nagar, right? So this is a guy. So take example, this is the Puneet, right? And this is the Praful, right? So Puneet has something, right? So he want to send something to the Praful. So normally what happened? He bought some phone, right? And what they will do that now they will encapsulate this phone. Encapsulation means what? The meaning of encapsulation means adding the extra header, adding some extra header. Header means what? You can understand in a simple way. Header is like a one cover. Normally, when you buy something from the Amazon, what happens? For example, you order some t-shirts or maybe some shoes, right? So they cannot deliver the directly shoes to you. So they will wrap up this shoes, okay, into the one box, and then he will deliver to you, right? That's called as the encapsulation. When you receive it, then you will remove the wrap, and then you can wear the shoes. That's called as a decapsulation. Decapsulation means what? Removing the cover, removing the header. That's the meaning of decapsulation. Extra header, or we can call it removing the cover. So we have a Puneet and we have a Praful, right? So Puneet bought some phone and he wants to send this phone to the Praful, right? So what he will do that he will just cover this phone into the one box. And now in this box, what he will do that he will put the source information as a what? HSR layout. And then he will mention that Bangalore. And in the destination, what he will do that he will mention that Delhi, sorry, not Delhi, Lakshmi Nagar. Guys, please pay attention. This is a very important topic is going on. And Delhi. Okay, so assume that, okay, your HSR layout is a MAC information and your Bangalore is a IP information. Same way, your Delhi is a IP information, your Lakshminagar is a MAC information. Okay. So when I'm going to put this information right into the, like when I'm going to put this information on this courier box, right, what I have to do that, I need a one guy who will carry these information. And that guy name is what? A courier person. Okay. So he's the courier guy. He has a own bus, right? He will carry all the luggage in this one and they will deliver to the correct location, right? If they have a complete information. If this have a complete information in this box, you need to give this box to this courier guy. This courier guy will take this information and they will deliver to the correct person. Okay, that's a media we have. This is the media we have. Take an example right now. What happened if I'm not gonna put the Lakshminagar over there? Then if I'm not going to put the Lakshminagar over there, normally when you give this information to the courier guy, right? When you give this information to the courier guy will not accept this information. Say, hey, you haven't put the correct information. The information is not completed. You need to put the complete information. You need to put the complete information. The information is incomplete. So normally that's a courier guy will tell that. Okay, when I talk about the networking part, right? When I talk about the networking part, when you don't have a information, completely information, when you don't have a complete information, when you don't have complete information, when you don't have complete information, in that case, what happened? When you don't have complete information in networking, they will throw the error message, and that error message is known as a encapsulation field. Guys, write down this error message. I'll show you this error message in the lab as well. This error message will help you everywhere. Not this technology, right? But many technologies. When you don't have a complete information, right? In networking, it will throw the encapsulation field error message, right? In a courier guy, it will just say that, hey, you haven't put the complete information. So when your encapsulation field will be there, right, in the networking, normally your packet will get dropped. Same thing, when you don't put the information, the guy will not take this information from one location to the another location. So you need to put the complete information. So what I'm saying that, understand what I mentioned that this guy, the Paschim Bihar we have, this Paschim Bihar is what? Sorry, not Paschim Bihar, Lakshminagar. This Lakshminagar is what? This is my MAC information. This is the MAC information. So you need to know the source MAC. You need to know the source IP. You need to know the destination MAC, and you need to know the destination IP. If you know all those things, right? If you know all those things, then you can send the information. Same thing is happening in the networking. When you have a complete information, source MAC, destination MAC, source IP, destination IP, then you can send the information. If any information is missing, you cannot send the information. Then encapsulation field error message will comes over there. Maybe you have a question here. No, I have seen somebody like, just only the MAC, based on the MAC, I can provide the connection. There is no need of IP. That's a different situation. Okay, understand the basic fundamental right now, because that's a very high level things. Basic funda is what? If when you don't have information, the packet will be dropped because of encapsulation field. Let's have a look over there. This PC, right? So normally, remember what you guys are doing that. Normally, you are sending the traffic to the IP addresses. You are sending the traffic to you are seeing the ping 1.1.1.2, ping 1.1.1.10. And normally when you go on the Google, what you are typing, you're just typing www.google.com, www.facebook.com, and www.twitter.com, or maybe the Amazon, Flipkart, whatever. You're not typing the MAC addresses. We are always sending the traffic to the home, the IP, the layer 3 information. So normally try to understand when I say the ping, when I say the ping is a command that works under the ICMP protocol. Ping is a command that works under the ICMP protocol. I say the ping 1.1.1.1.2. So when I say the ping 1.1.2, what I told you that the ping is a command right? That works under ICMP protocol, right? ICMP is a layer 3 protocol that works on the network layer, right? And it has, right? It has some own message type. Message type you can understand in this way. Every person has a different message type when they are communicating to the person. So normally what the global message, when you're talking to someone on the phone, the first message comes in the picture is like a hello. So when you're calling someone, the first word that comes from your mouth is like hello. And when the opposite person will give you the hello message, it means that the communication is bidirectional. Now we can exchange the data. Same thing, ICMP also has a message. They have a different message. The most important message we have is called as a request and reply. So when this person when I say the ping from this guy 1.1.1.1.2, so I'm generating the traffic. This guy PCA is generating the traffic to the PCB, right? So he will send the request message to this person, and this request passes. So this is the ping command, right? That I've used. This ping command works on the ICMP protocol, and this ICMP is going to utilize this message now to verify the connectivity. To verify the connectivity. So when I say the ping 1.1.2, so I will send the request packet. If the PCB is available, listen to my carefully words. If the PCB is available, he will give you the ICMP reply message. And now you will see the exclamation mark over there. The communication is successful. So by default, if you guys remember that yesterday we have seen that in a unicast, right, you are sending the 5 packets on the Cisco router. This behavior is different on the vendor by vendor. On a Cisco, you are seeing the 5 packets. So you will see the 5 exclamation mark of there. This exclamation mark represent that, right? This exclamation mark represent that the ping is successful. It means that you have sent the data correctly. It means that I have sent the request packet and he will give the reply packet. So you will send the 5 request packet and he will give the 5 reply packet. That's a default behavior on the Cisco router for the unicast packet. But take example, if somehow I send the packet, right, but I'm not getting the reply. I send the request packet, but I'm not getting the reply. So what happened in that case? So you will see the message like this, right? The drop. That's a simple way, right? Now have a look out there. So when I say that ping, when I say the ping 1.1.2, normally what happened in the background, I will generate the ICMP request packet. So when I'm going to generate the ICMP request packet, I will create my header, right? In this header, we have a source information. Right? Then we have a destination information. Right? Source information, destination information, right? The layer 2 and layer 3, right? So source information will be what? You have a source MAC will be destination MAC. You have a something called as a type field. right? Then we have a source IP information. And then we have a destination IP information. Help me out. What will be the source MAC? What will be the source MAC?
MAC A.
Sorry?
Make A.
MAC A, right?
Make A.
MAC A.
Yes.
Okay.
What will destination MAC?
Make B.
MAC B.
Do I know the MAC B?
Nope.
What you know?
1.1.1.2, sir.
You know the 1.1.1.2, right? That's the IP address. You don't have a knowledge of the MAC B. So MAC B will be empty. So you will have a what was source IP address. That's a 1.1.1. And destination will be 1.1.2 because you are sending the traffic to the 1.1.1.2. And here you will have a type field. Okay.
Yes.
This type will be 0x800. I'll let you know about this guy. Don't worry about that. Okay. So you have a source MAC. You know the source IP because I'm sending the traffic. I'm sending the traffic to the ping 1.1.2. I know the destination IP, right? But I don't have any awareness of the destination MAC because I have no idea. Normally, you know the Facebook.com. You know the Twitter.com. You know the Amazon. So you know the IPs. So this is the ICMP request packet, right? So in this case, what happened? This ICMP request packet does not have a complete information. So this packet will go on the hold. You can say that right now. Normally this packet will be dropped. Okay, you can say that, but I'm not using this statement. This packet will be on the hold right now. I'll tell you why. The reason is a hold right now because I don't have a complete information. So when you don't have a complete information, because I don't have a MAC information. So if you don't have a MAC information, what you have to do that? Now we need to bring a new person, and that new person is known as a ARP. So I have a one protocol is known as a ICMP. Till this point, we have seen that under the ICMP, we have two major types of message: ICMP request packet, ICMP reply packet. So normally when you send the ping from this user, he will generate the ICMP request packet, and you can see that this packet will go on the hold. Reason being, I don't have a destination MAC. Same example that I gave you, right? If you don't put the Lakshmi Nagar, right? If you don't put the Lakshmi Nagar, what happened? The courier guy cannot accept this packet, right? Same thing. I don't have a destination MAC information. So when you don't have a destination MAC information, what happened? I need someone who can, guys, please be on mute. I need someone who will bring the MAC address information for me. So that's why the ARP comes in the picture. ARP is another protocol. So till this point, we have seen the two protocol now. One, ICMP. Majorly, if I talk about, we have two masses. Right? And now another protocol we have focus on the name, address, resolution, protocol. Now, what is the main person? I'm coming to the Nasir. So that's an ARP, right? Address, resolution, protocol. The name focus, if you see address, which address you're gonna resolve it. I'm gonna resolve the address, which address you're gonna resolve it. So with the help of ARP, this guy is gonna resolve the layer 2 information. This guy is gonna resolve the MAC address information. Have a look the name, resolution, right? I'm gonna resolve the MAC address information. Which MAC address information I'm gonna resolve? I'm gonna resolve the destination MAC address information. So normally, when you send the ICMP request packet, if the PC doesn't have a destination MAC information, then it will generate the R reply packet. When the PC doesn't have a destination MAC information, it will generate the R reply packet. And now in this R reply packet, the same information will be there. You have a source MAC, right? You have a destination MAC. Sorry. You have a source MAC. You have a destination MAC. You have a something called a type field, and then you have a source IP and destination IP. So source MAC will be again the PCA now. Okay. Destination MAC, I have no idea what is the destination MAC. So normally when you don't know the person, take example, just imagine that you are in the new person in the classroom, right? So that's a day one for your class. And you know only one person. So your principal said that just go and meet to the Amit. So, but you don't know the Amit. So what you will do that? So normally when you go into the classroom, you just making a broadcasting. Hey, who is the Amit over here? Who is the Amit here? So same thing, I have no idea what is the MAC address of the PCB. So what I will do that, I will use the broadcast MAC address. The broadcast MAC address is FFFF. I cannot use all the 12 digits over there, so I'll just put the FFFF. And then after that, we have a type field. That's called as a 0x806. I'm coming to the type field, don't worry about that. Then after that, we have a source MAC. The source MAC will be again A. Destination MAC, I have no idea. I will put the 000, right? Source IP, I will put the 1.1.1.1, and destination I will put the 1.1.2. Understand? This information is your Ethernet information. This information is the ARP header information. Two information in this packet. One is called Ethernet information, one is called ARP header information. So now this PC will generate which packet? This PC will generate the ARP request packet. This is called the ARP request. Sometimes people also say that this ARP request packet is a broadcast packet. Sometimes people are say that this ARP request packet is a broadcast packet. The reason being because we have a broadcast MAC address over there. Now this PC1, right? The first packet that was my ICMP request packet was on the hold, right? It is not dropped, it's on the hold. Now after what happened? Immediately the PC1 will generate the ARP request packet. When the PC2 will receive the ARP request packet, when this PC2 will receive this ARP request packet, what he will do that? He will say that, okay, the packet is coming from the MAC address A, that's a source MAC address A, PC1. Okay, this packet is a broadcast packet. Okay, that's fine. Still the PC2 is not able to identify, is this packet is for me or not? Guys, please pay attention. Still PC2 is not able to identify based on this information that is this packet is for me or not. Okay, so when the PC2 receive this packet, it said that source MAC is A, that's fine. Destination MAC is FFF, it means that this is the broadcast packet. Wait a minute. There's something called the ether type field, 0x0806. This ether type field, right? This ether type field is present on Ethernet header. It is a 2 byte field. Right, that contains the upper layer information. It means that after the data link layer, we have a network layer, right? So if you have a 0x0806, that's a hex value, right? This is the hex value. So if you have a type field is a 0x0806, that's gonna represent that this is the ARP packet. It means that we need to perform the lookup for the ARP. If you have a 0x08000, then I need to perform the lookup for what? IPv4. You have a huge variety of range. Okay, I'll just give you the few one. If you go for the 0x8847, it means that the router, so data link layer has to perform the lookup for the MPLS unicast. If you have a 0x,
Sir, please repeat.
oh, hold on, I'm repeating.
No.
This MPLS multicast. Right, same way, if you guys have awareness of the VLAN, right? So most of the people are the experience over there. If you have VLAN, so VLAN has something called as a 0x8100, I think so. That's for the 80.1q protocol.
Yes, yes, sir. One is
You have a bunch of something. Let me show you this thing. So basically, it's a 2-octet field, 2-byte field in the Ethernet header, right? That's just gonna identify that, okay, the upper layer information, upper layer in the sense of what? Whenever the packet is received on the, right? So normally on the physical layer, you will receive the packet information as a what 01010101, right? So this 0101 will be converted into the frame format, right? On the data link layer, right? And on this data link layer, we have a now what? A network layer. So how does this data link layer decide? Should I forward? So normally, if you have a MAC traffic, right? If you have a layer 2 traffic, then you need to send this layer 2 traffic on the layer 2 only, on the data link layer only. There is no need to send on the layer 3. If you have a layer 2 traffic, then you need to route the traffic according to the data link layer only. You don't need to go on the network layer, right? So how does I should decide, should I forward the packet to the network layer or not? So that comes in the type field. Type field will be decided, should I forward the packet to the network layer or not? For example, if you have a 0x8100, that's a VLAN traffic, 80.1q protocol traffic. This works on the layer 2. So in that case, I don't need to send the packet to the layer 3. Who is going to tell me? That comes on the type field. So if you take example, if the packet is something like this, we have a source MAC A, distance MAC B, right? And 0x0806, right? That's what? That's for the ARP, right? So in this case, again, I don't need to forward the packet to whom? Network layer. Because it comes on the data link layer 2. But if you have a packet, something like this, source A, distance B, and 0x0800, right? That's for the IPv4, right? That's for the IPv4. It means that I need to forward the packet to whom? I need to forward the packet to the network layer. That's why it's saying that every layer, the down layer, every layer has some information about the above layer. Every layer has some information about the above layer. On the data link layer, we have something called as a type field. On a network layer, we have something called as a protocol field. You will get to know that gradually, don't worry about that. On a data link layer, we have a type field. On a network layer, we have a protocol field. On a transport layer, right, we have a port number. And then after that, we have a remaining one was what? Session, presentation, and application. These are pure data field. So I will have a port number. Based on the port number, what I can do that? Based on the port number, I can directly send the packet to the application layer. Every layer has some information about the above layer. Type field, that's a most important field, is going to decide, should I forward this packet to the upper layer or not? So if you go with the interviews, like a very high level of the interview, right? They will ask the question, okay, tell me what is the type field for the MPLS? Okay, tell me when the router will receive the MPLS packets, what he will do that? And how does router will decide should I perform the label forwarding or the IP forwarding? When a switch receive the packet, or when the router receive the packet, right? How they will decide that, okay, should I forward this packet to the network layer or not? That comes in the type field, because each type field has an information. If you have a layer 2 information, go with the ARP. If you have layer 2 information, go with this one. If you have a bunch of type field, if you can see that, right? If you have a time, go with this one. If you have an ARP, you can see that 0x0806 ARP IP port we have. V6 also we will have a 0x6DD something called as a, yeah, see. MPLS unicast we have, MPLS multicast you have. Every information has a type field. So when this information comes in the picture, right? When the PC2 receive this information, he determined, okay, this information is coming from the MAC A, fine. This information is for the broadcast, that's also fine. It means that this packet is not for me till now. Okay, this is the broadcast packet. When he see that, okay, 0x0810, this is the ARP one in the Ethernet header, you can see that, right? What PC2 will do that? Now he will open the ARP header. In the ARP header, we say that, okay, the MAC is A, that's a source MAC. Destination MAC is 000. It means that someone is looking the MAC address. Who is someone? The PC-A is looking the MAC address of me. How does the PC2 decide? Based on these information. So before replying the ARP request, what he will do that every PC maintain the ARP table, right? Every PC maintain the ARP table. First, when it will receive the packet, what he will do that he will update the entry. So he said the IP plus MAC. So in the IP, he will mention the 1.1.1.1 associated with the MAC A. Now he put the entry, it's called as the ARP table, or we can call as a mapping table of the 32-bit to the 48-bit. Why is it the 38 to the 48-bit? Simple reason, because 32-bit is a MAC address information. Sorry, 32-bit is a IP information, right? And 48-bit is a MAC information.
A quick question, if you don't mind,
Yeah.
because I got disconnected in there. So the reason why this packet or this, has the host A decides to put this Ethernet or the type header of 0x0806, which is the ARP, is because host A determines that it doesn't have the destination MAC address. So it decides, okay, this is what I need to.
Yeah, so
this is
when the
the
PC2 receive
type,
this
okay.
packet, right? So till understand this concept first. When the PC2 receive this packet, what he will do that? Okay, let me put this packet over here, right? So when the PC2 copy and paste, when the PC2 receive this packet, what he say that? Okay, MAC is A. Okay, that's fine because my MAC is B. So my MAC is A, that's fine because someone is sending the packet. Okay, this packet is a broadcast packet. Okay, this packet is not dedicated for me. That's fine till this point. After he said the Ethernet as a type field 0x0806, that's for what? ARP. It means that I need to perform the one more lookup. I need to perform the one more lookup. Which lookup? Because it's saying that you need to perform based on this guy. The Ethernet header is saying that you need to do the lookup for the ARP as well now. You have extra information in this packet. So when the PC2 is looking for the extra information, that's the ARP one. Again, he said, okay, the PCE is sending this packet. That's fine. It doesn't have a MAC information. 000, empty. 00 means what? Empty. Doesn't have a MAC information. And who is sending the packet? The PC1 is sending the packet. The 1.1.1, he's sending the packet. And he's sending the packet to me only. It means that he's looking for my MAC address information. Now you got it?
Okay, got it. Thank you.
Now, so when the PC2 will receive it, what he will do that? He will update the MAC ARP table entry. ARP table is nothing but just a mapping of the 32-bit to the 48-bit. Okay, you can also call as a layer 2 to the layer 3 to layer 2 mapping, right? Now what PC2 will do that now. PC2 will generate the ARP reply packet now. So when the PC2 is going to generate the ARP reply, right? So you have a same information, right? You have a source MAC, you have a destination MAC, right? So this will be Ethernet header. This will be ARP header, right? Source MAC will be what now? Tell me. What will be the source MAC? What will be the source MAC?
B,
B, right? What will be the destination MAC?
A,
Great, because I
A.
have information now. So whenever the PC will send the packet, it will perform the lookup in the ARP table. And if the ARP has the information, he will take the information from it there now. What will the type field? Still 0x, right? 806. Then source MAC again B, distance MAC again A, source IP will be what? 1.1.1.2, and distance IP will be what? 1.1.1. This packet is a pure unicast packet, and that's why I put the mention of the U keyword. Now the PC2 will send the reply packet to the PC1 now, right? Right? When the PC1 will receive the reply packet, when the PC1 will receive this reply packet, what PC1 will do that now? PC1 will receive this information and they will update the ARP table now. You see the IP will be and MAC will be, once I will receive this information, what do you think? How long it will take to process this one on the router side, on the PC side? So normally on the Cisco router, understand this concept, this packet was on the hold till now, right? This packet was on the hold. So normally on the Cisco router, when I say the ping command, understand this concept. Normally on the Cisco router, when you say the ping command, I say the ping 1.1.1.1.2. I mentioned that ping is majorly use the two types of message type, ICMP request and ICMP reply. Apart from this, we also have another type of message. So when you say the request packet, right? I will send the first request packet. If I'm not getting the reply, how long I should wait? The first question. If I'm sending the something to you, normally when you're talking to someone, you say the hello. If somebody, the another side person is not replying you, right? You have to wait for some moment, right? And then again, you will say the hello. And again, he is not responding. Then again, you have to say the hello. Same thing is happening on the Cisco router. So normally on the Cisco router, when you say the ping 1.1.2, I will send the ICMP request packet. If I'm not getting the reply from the another side, right? If I'm not getting the reply from the another side, from the PCB, what he will do that he will wait for the 2 seconds. That's called as a timeout of the ICMP, the default timeout. You can change it if you want. That's not a big deal. That's a 2 second is a by default timeout. So if I'm sending you something, I'm waiting for the reply within the 2 seconds. If you're not going to reply me within the 2 seconds, then I will send another ICMP request packet. That's a default is 5, right? On the unicast. Again, if I'm not getting the request, I will wait for the 2 seconds. Again, I'm going to send the ICMP request packet again. Take example, if I get the reply of the third packet, right? The first and two, I'm not getting the reply. If I got the reply packet of the third packet, what I can say that the first two packet get dropped, third packet is successful. And this two packet get dropped, right? Because of the timeout. But in my case, in this topology, right? What is happening? I don't have a destination MAC information. So what happened meantime, this guy comes in the picture, say that, hey, don't worry about that. You don't have a MAC information. I will get the MAC information for you. PC1 has sent the ICMP request packet, right? This request packet was doesn't have a MAC didn't have MAC information. So the ARP comes in the picture, say that, hey, don't worry about that. I will get the MAC address for you. But normally this protocol took more time to get the MAC address, more than the 2 seconds, right? And that's why eventually what happened, this packet will get dropped now because of the, you don't have information. It took the more than 2 seconds. And now it will throw the error message. That error message will be encapsulation failed. Now the first packet get dropped. Now the second packet, once I get the reply, right? What happened? Now I will complete this information. So when I send in the second ICMP request packet, this is my second ICMP request packet, I will perform the lookup in the ARP table for the destination MAC. I know the destination MAC. I will send the packet to the PCB. Because now I have information in the ARP table, right? So whenever the PC is sending the traffic for the layer 2, it look up in the ARP table. Even on the router side, if I talk about, router also perform the lookup in the ARP table. You need to know the layer 2 and layer 3 information. So when this packet comes to the PC2, now the PC2 will give the reply packet. In the reply, what happened? In the reply, you have a source MAC now B. Destination MAC will be A. Source IP will be 1.1.2. And destination IP will be 1.1.1.1. And this is my ICMP reply packet. So normally in norm background, right, all these things is happening. So first you will not have a ARP information in your ARP table. So he will send the ICMP request packet, but this ICMP request packet is not completed one. So normally, eventually this packet will be dropped. But firstly, this packet was on the hold. The reason being, I'm looking for the information. Okay, but eventually I haven't received the information within the 2 seconds. That's a timeout of the Cisco router. Okay, Windows has a different timeout, normal PC. Okay, Cisco router has iOS. Windows laptop has a different iOS. It's a Windows. Apple has a different one. So everyone has a different behavior. So I haven't received the reply within the 2 seconds. That's why what I'm doing that. I'm dropping this packet. And the reason being I'm telling that encapsulation failed because I don't have a complete information. Then I got the information through the ARP, and now I'm sending the complete information to the PCB, and PCB is replying to me as well. That's how your normal communication is happening, right, in networking. So if I tell you the, like, Cisco packet tracer, first let me show you on the Cisco packet tracer, then I'll show you the detail on the GNS3 as well. I must have. So let's take example. I have a PC. PC1 and PC2. I'll take the crossover. And now I'll put the IP. So I'll put the IP for this guy's 1.1.1.1. I'll put this guy's IP is 1.1.2. Right. I'll also take the MAC address, copy the MAC address information from here to here. So let me copy the MAC address information. Let me first define the IP. To this guy's 1.1.1/8 and command prompt IP config / physical addresses. This one. That's called the MAC address. So that's the MAC address of the PC1. Desktop IP configuration 1.1.1.2. And then I'll look for the IP config /all. That's a MAC up to. It's a question. Someone asked a question. In this scenario, hold down time is a 2 second. What is the name of the protocol running? ICMP. That's it. So now let's have a look. I'll just open the simulation. And I'll put the packet on this PC1. Okay, that's the source. Destination is this guy. Have look in the background. Can you see that? I generated the ICMP request packet. This ICMP request packet is on the hold, right? If you open this ICMP request packet, you can see that this is the request packet. Okay. ICMP echo request packet. And now in background, what happened? Immediately I generated the ARP request packet now. That's a PC1 generated. If you see that, that's a layer to Ethernet information where we have a 000D0. That's a MAC address of this PC1. See that 58129395. Right? And the destination MAC address is the broadcast FFFF. Source IP will be under 1, destination IP will be under 2. I'm sending this packet from the layer 1 port number 0/0. Sorry, 0. And now I'm sending this information to whom? I'm capturing forward. This packet comes to the PC2. What PC2 will do then? It will receive this packet, open the PC2 now. And if you see now, this guys, ARP minus A. I have information on the PC. I learned this information as a dynamic. You do have ability, you can put the static. Don't worry, we'll discuss this thing later on. Leave it right now. Focus on this part.
Question, not very important, but in Packet Tracer, it does show that the type section or information.
So type section I can
Okay.
show you in the type section. I will show you in the Wireshark. Don't worry.
Oh, okay. I was just curious. That's all. Thank you.
It will not show you over here. I will show you in the Wireshark. So when the PC2 receive this information, right, the ARP request packet, so I can see now the PC2 is able to build the ARP table. Forget that this type dynamic right now. Okay, leave it. We haven't done. We have almost 2 more hours of the ARP classes, 3 hours more of ARP classes. Understand the basic funda. Okay.
Okay. No, I was asking about the type 0x.
That's I'm coming. That point.
Okay. All right. Thank you. Just.
So now, if you see the same ARP minus A information on the PC1, let me show you this one. It doesn't have it till now. It doesn't have. Okay, doesn't have. So when the PC2 will give the reply, right, now it received the information. Previously it doesn't have. Now if you put the ARP minus A, now I have the information 1.1.2. So on the PC1, you can see that I have a 1.1.2, the MAC address 000D0. 5835, that's a 5835 this guy. So this information is present over there, this information is present over there. And now I'm sending the ICMP request packet. Now I'm sending the ICMP request packet, and now the PC2 will give the ICMP reply packet. If you open this reply, you can see that. How you can identify which one is the reply, which one is the request. So you can see that this type 8, can you see that the type 8 value, the 8 number, the type 8 is going to identify this is the ICMP request packet. Let me mention over there. Type 8 is going to tell you the type ICMP request packet. Type 0 is going to tell you that ICMP reply packet. This is a type 0. That's ICMP reply. Yeah, ICMP request is type 8 and reply is a type 0. Yeah. So based on the types, you are going to identify which one is a reply, which one is a request packet. Tell me if you have any question till this point. Then I'll come to the Wireshark as well.
So again, that was at the layer 3, right? When it showed the ICMP request type and reply type. If we go back to the layer 2, will it show that the ARP type or no?
The 0x0, you are looking at the ether type?
Yeah.
Yeah. I'm coming to the point now.
Okay. Again, sorry. Got it.
So now let's come to the Wireshark. So this on my GNS3, I don't have a laptop. I have a router over there. Okay, so I just changed the icon of this router, nothing else. So you do have it. You can also change. You can just need to go in the symbol and change the things, right? If you want. So I have just changed the symbol, but actually this is the router, not the PC. That's a MAC address of the router 1. That's a MAC address, the PC 1012. That's the IP address of this PC and the MAC address of this guy. And now let me open my console. Okay, let's give the let's give the first IP addressing on the router side. So the so IP first check, do we have any IP configured or not? That's a very beautiful commands we have. So IP interface brief, right? Whenever you do the configuration in the production network or even in the examination, always do the first verification. So IP interface brief, I don't have any interface configuration right now. All the interface is downstate. So let's configure it. Interface 0/0. IP address will be 1.1.1.1/8 and I say the no shutdown. That's done, right? Basic part we have done yesterday, right? On R2 interface 0/0, IP address will be 1.1.1.2, no shutdown, and that's done. Okay, done. Let's ignore it. So if you go on the router 1, okay, let me capture this particular link. And first I'll show you the ARP information. So ARP, I just have a own information right now. So on a router 1, I have a protocol is an internet protocol, right? Address is 1.1.1. That's my IP address of this particular interface. Age means time. Age means like how long back we have learned this MAC information. So for me, of course, there's no I'm learning any information. That's why it's the infinity value. This value is gonna represent infinity. It means that we are not learning this information. This is my own information. Okay. And that, but if you're learning the information, for example, when the router 1 will learn this information of the router 2 MAC address, then you will see the timer over there. I'll let you know what is the timers and everything. Then after that, we have a hardware address. Hardware address is nothing but it's just a MAC address and physical address of the particular interface. Then type is a what? It's a encapsulation is a ARPA. Okay, and interface is 0/0. ARPA is a stand for Advanced Research Project Agency. So there's a multiple courier guy, remember? So when you order something from the Amazon, there's a multiple courier guy. Maybe some company XYZ, company ABC, company DCD, right? They are couriering your service, courier services providing you, right? To deliver one product to the one location to the another location. Same thing. We have a multiple types of protocol. Okay, I'll show you how to change this thing if you want, but that's not important right now. So this is just an encapsulation type we have to carry the ARPA information. So I just have own information. Okay. Now I said the ping. Before I'm gonna ping, I said the debug IP packet. What? Hold on. Debug ARP. Debug IP packet. Detail. And debug IP packet detail and debug ARP. So data 1 is the ping 101.2 now. Hit ping. Okay, so you can see the capture. So I sent the ICMP request, sorry, the ARP request packet. So you can see that. So the source information you see over there, C201, that's C201 is the router 1, is doing the broadcasting on the destination address. If you open this packet, right? And let me put it in the paint file, then explain you over there. Okay, and I'll take this one as well. That's a reply packet. And I'll put the diagram of the topology as well. Okay.
Hello.
Yeah, go ahead.
Sir, what is which software sir you use?
I'm coming to the point. Hold on. I'm coming. Just understand the basic right now. So when I send the packet, right, from the PC one, so you can see that we have a source MAC information, right? That's a C201. You can see that C201, that's a MAC information of the PC1. This is the ARP packet that PC1 is sending to the PC2, or we can say the router 2. And this is a MAC address in the Ethernet. We have a broadcast, right? Same thing we have mentioned over there as well. Can you see that? In an Ethernet header, destination MAC address is a broadcast. Then after that, we have a ARP header field, type field. Same thing now you can see that we have a type field over there. That's a 806. And now the product, then I have to perform the Ethernet lookup is now Ethernet is going to send the packet to the home ARP. So now when he's going to send the packet to the ARP, now you can see the ARP header. In the ARP header, this packet is a request packet. Okay. The hardware type is, you can see that it's a Ethernet. It means that we are using the technology as Ethernet. It could be changed if your technology is different. So for the Ethernet, you're going to use the value 1. For the Ethernet technology, you're going to use each technology has some decimal number, right? So because normally your PC understand the 01010101, right? PC doesn't understand the English language and not even the decimal. He only understands the binary language. So every technology has some like a hex decimal or decimal number so that the PC will convert into the binary one. But if you're gonna use a different technology, right, you have different values over there. I had a list of values, right, long time back. I don't know which notepad I have saved it somewhere, but yeah, it's a lots of values. You will see that. But the value 1 is a very important one, right? When I'm gonna teach you the DHCP, right, dynamic host configuration protocol, I'll show you the use of this value 1. Then after that, we have a protocol number. Protocol is what? It's a IPv4 protocol. That's a ether value is what? 0x0800. Hardware size, that you can see that it's a 6 byte. It's gonna represent that it's a MAC information. 6 byte means what? MAC information. Protocol size 4 byte means what? IPv4 information. Then opcode, that's meaning it's the operation code. Operation code means operation. What is the use of this packet? What is the packet is this? It's a request packet, and for the request packet, the value is 1. Same way, the request reply packet, the opcode is what? Value is 2. And then we have a center MAC address is what? C201, that's a PC1. Center IP address is 1.1.1. Target MAC address is what? I have no idea. But to whom I'm targeting? I'm targeting for this guy. So it means that this ARP packet, right? This ARP resolution packet is requesting for what? Is requesting for the MAC address of which PC? This PC, 1 or 2. Same thing. Now this person will give the reply packet. So destination is C201, right? Source is C202. That's a PC2. Destination PC1. Again, this is the ARP packet 0x080006. It's the ARP reply packet. Ethernet header is same. Protocol is same. Everything is same. Apart from only the difference is that here you will see the 000. Now you don't have a 00 because PC2 has a complete information. That's why it's called as a unicast packet. This is called as a broadcast packet. Let me know if you have any question in the header part. This is called as a header. ARP header.
Oh, this is just the ARP header, right?
Yeah.
Okay. Because
This part is the Ethernet header.
Okay. No, because just a quick question. A few minutes ago, you had mentioned about the ICMP reply type and request type.
Oh, that's come over there. You can see that. So after the sending the ARP exchanging, right? Now we can see the echo request and echo reply. So if you're gonna open the ICMP, so now in the ICMP, what happened? Hello?
Yeah, I'm listening.
Just give me 1 minute. So now in the ICMP request packet, you can see that, right? What happened? You have a source MAC C201, right? The most important thing, if you see, type field. Then
Okay.
see the difference is that in the ARP we have a 0x0. Now because it's a layer 3 packet, right? So we need to say that on the layer 2, hey, you need to forward the packet to whom? Layer 3. Because this packet was a complete layer 2 packet. That's why I'm saying, hey, forward the packet to whom? ARP only, not the layer 3. And this packet is saying that, hey, forward the packet to whom? Layer 3. And now we have a layer 3 ICMP protocol. Source IP 101, destination IP 102, and ICMP uses the protocol number 1. It's a very important question in the interview. What is the protocol number of the ICMP? The protocol number is 1 for the ICMP. And now we have ICMP control message equal request packet. The type is 8.
Got it. Thank you.
And here we have a data, right? The meaning of this dot means what we have a use data, right? Maybe you have a question, Law, what about this thing? Don't take so much stress right now. You will get to know that each and everything. ICMP layer 3 packet is running on the layer 2. No, ICMP layer 3 packet is running on the layer 3. ICMP is a layer 3 packet, it will run on the layer 3 side, not the layer 2 side. Right, now have a look on the debug information. That's a very important because this debug will help you to understand and troubleshoot the network. See the router 1. Right? Guys, please pay attention. Okay. No, but switching is related. Yeah, switching is related. Nasi, just give me 1 minute. I'll just come back to you as well. Just give me 1 minute. Hold on. So you can see that when I said the ping 1.1.1.2, right? So on that time, I didn't have any ARP informs on the PC2, right? I don't have. Now, if you see the when I said the ping 1.1.2, sending the 5 packets, which is by default of the unicast, the size of packet on the Cisco router is the iOS router is 100 byte. Again, I'm repeating, iOS router is 100 byte. ICMP equal request, which means that each packet that total I have sent the 5 packets, right? So I'm sending the 500 bytes of packet. 100 byte each. Okay, so now the time it is what? 2 seconds by default. So I'm sending the packet source 1.1.1. That's our router 1. Destination 1.1.2. I'm gonna route this packet from this particular interface. Okay, source is the 1.1.1, destination 1.1.2. The size of this packet is 100 bytes. Sending the which packet? ICMP type 8. It means that equal request packet. What happened? I had no idea about the MAC informs of the PC2. What he will do that? I'm creating the ARP incomplete entry. You will get to know that what is the meaning of incomplete entry by Monday. Don't worry about that. Okay. But I'm creating the entry for the ARP. I'm creating the entry for the ARP now. For which purpose? For the PCB purpose, PC2 purpose. And now I can see that I'm sending the ARP request packet. Source 101 C201. Destination is 1.1.2. And that's a MAC address of this guy. I have no idea. That's why I'm sending 0.0. I'm routing this packet from this particular interface. The error message. Remember that I've shown you that encapsulation failed. Why? I have no idea. And this encapsulation failed error message is the ICMP message, not the ARP one. See IP. And now once
Could it be that for the first packet that usually drops into the ping?
yeah, now it's drop, right? So now after receiving the request packet, right? Receive the request packet from the, sorry, receiving the reply packet from the PC2. Now my first packet is dropped just because of the encapsulation failed. Can you see that? Encapsulation
Okay.
drop, and now
Gotcha.
the remaining packet is successful. So same thing when the PC2 receive it. Can you see that? So PC2 has received it. Right? See the difference is happening what? PC1 was creating the incomplete entry. It means that incomplete means what? PC1 is saying that, hey, listen, I'm creating the space. Incomplete entry means what? I'm creating the space for what? Creating the space for the PC2. So I will just mention that, okay, 1.1.1.1.2 type is a dynamic, but I don't know the any MAC address. That's over here. It will written like an incomplete over there. I will show you that. Don't worry. You will see that incomplete over there. And that's why on the PC1 it's an incomplete entry. But when the PC2 will receive it, he is not saying that it's an incomplete entry. He's saying that let me create it. Why? Because PC1 is sending the complete information to the PC2. So if the PC2 is receiving the complete information, he will create it. And he's creating the entry for this guy. And now he's giving the reply to the PC1. And after that, my ICMP comes in the picture. And now you can see that on the router 1. So once I receive it, try to understand. So when I have sent this ICMP request packet, right? Now the PC2 will give the reply packet. Once I receive the reply packet, if you see one thing over there, I receive the reply packet. Once I receive the reply packet, what I will do that? I will change this incomplete to what? As a MAC information. C202. Got it? So creating the incomplete entry, the meaning of incomplete entry means what? I don't have information. Let me create some space for that one. I will not put the MAC address until I received it. Once I receive the MAC address information, I will remove the incomplete information from it and I will put the exact MAC address. And now if you see, so I learned this information 13 minutes ago. So the PC1 has information 1.1.1.2, this guy. Now if I'm gonna send the packet, let me you all, I don't see any drop. Why? Because I have a complete information now. I have a complete information now, so I will not see the any kind of drop. Same thing on the PC2, if you look on the router 2, I can see that. So I have information. I learned this information 30 minutes ago. So there's two commands. One is called as ARP, one is called as show IPR. To verify the ARP table. This is called as a ARP table on the router side. Now you may have a question, what is the difference between show ARP and show IPR? Nothing big difference. This was the very older command, right? If I talk about in the 90s, 80s time, right? On that time, IP was not a dominant protocol. Every vendor has a different protocol mechanism, right? You have a 90s, 80s time, we have an AppleTalk, right? We have DECnet. These are the companies, right? We had IDBM. So they are different organizations who are putting and some other vendor. Okay, so different vendor have a different protocol. Apple has their own protocol to communicate itself. IBM DECnet has their own protocol to communicate itself. Some other vendor has their own protocol to communicate itself. So on that time, right, they have a own layer to inform them. So that's why we were putting the show ARP information. IP was not dominant on that time. Now IP is a dominant protocol, right? IP is everywhere. Previously, IP was not everywhere. So this is the older command. So if you put the show ARP, you can see the AppleTalk information, IBM information, DECnet information, everywhere, everything you can see that. But if you put the show IPR, it will only show you the IP information. That's a major difference there. So I have a ARP information now, and I can send the traffic. So if I'm going to send the traffic now, I will not see any kind of drop. No drops down. It's purely ICMP request packet. There is no ARP. So you can see now, there's no request packet. It's all are there's no ARP, all are the ICMP request packet and reply packet. There's no ARP is going on. So this information that you have learned, 15 minutes ago, this information is just a valid for the 4 hour. That's called the ARP timeout. On a Cisco router, iOS router. This is very depending on the operating system. Nexus maybe has a different, Accept has a maybe different. So yeah, iOS has a 4 hours. So now I can see it. So interface 0/0. I can show you that. And if you see, the encapsulator is ARPA, timeout is 4 hours. Yeah, good to go the questions. But switching is a layer 2. Okay. Switching is a layer 2, routing is a layer 3. Nasir.
That's fine. But the question was it.
What was the
Uh,
question?
But no, we are talking about the switching, isn't it? So
So on the Monday, we are going to talk about the switch in between as well. So we haven't done with the ARP. We have almost ARP for the next 3 hours more.
no, that's fine. What I'm saying, but right now we are talking about the switching. So if
Yeah.
we are, this is
We are talking about the switching, right? But again, what I told you that, I think so you missed this point. So for the verification, what you have to do that, you need to use the ping command, right?
yeah, that's right. Yeah.
And for the ping, what protocol we have?
Oh yes, ICMP.
And ICMP has which message type?
Type 8 and type 0.
Type 0 and type 8, request and reply, right? For what?
That's right, yeah.
Verify the connectivity. So
Correct.
it comes in the picture, even in the layer 2 as well.
Yeah.
The meaning of layer 3 means what? Let me tell you. The meaning of routing is what? The meaning of
Exactly.
routing on layer 3 means what? You're running the routing protocols over there.
That's right.
In a layman language, in a simple language.
Yes.
Right?
Yes. That confused me actually. Yes, that's right. Yeah.
Guys,
So obviously,
yeah,
so
sorry.
no, sorry, I'm not finished yet. So the meaning of layer 3 is a routing protocol, right?
Yeah,
So I thought, so obviously
right
the
now,
layer
just
2
for the
is,
layman language, but when you go in the very experience in this one, then you will understand the, okay, routing is, layer 3 is not only meaning the routing protocol. Layer 3 means has a different meaning as well.
I see. So, okay, fair enough. So, I mean, basically, when we're talking about ICMP3, when we were pinging, that means we're talking about ICMP, that means we are talking about layer
Layer
3.
3,
Simple.
right,
Simple.
simple, yeah.
Okay, that's fine.
So-
Thank you so much. Right.
So I guess and again, correct me if I'm wrong, but as I understand correctly, even though we were talking about switching or the layer 2, the reason why we have ICMP and layer 3 picture is because we are
Ping,
doing the ping commands from the host computers, which
yeah,
then would act from at layer 3. The whole ping
because
command
ping
from the
is
host
totally
computers.
dependent on the ICMP protocol. And ICMP has this massive time. It's a dependencies there. So even if you're on a layer 2, you need to verify the connectivity. How you would verify the connectivity? ICMP, right?
Right.
So there is a let me pause the recording. I don't want to share this info on the recording.
Yes.
Okay, you were
Yeah.
said ARV will be timed out after 4 hours. Okay. Then again router 1 send to router 2 again send to the ping.
Again, yeah, that's I wanted to discuss this thing on the Monday. Yeah, again he will do that. So if you don't have again ARP entry, then even you have to send the ARP request packet. Okay.
So router will automatically will be doing.
Yeah, automatically you don't need, by default this protocol is enabled.
Uh,
By default, this guy is saying, hey, by default, I will be present everywhere. So you don't need to worry about that mean. He's present everywhere. On an Ethernet.
So I guess,
only
but that
on the
would be
Ethernet
dependent.
technology.
That would be dependent or subjective to the fact that the other side is still up and active, correct?
Right, up and active, right.
Okay.
So ARP is only comes in the Ethernet technology. If you're gonna use the serial link, right, you will not see the ARP over there. The reason being on the serial link, right, you don't have a MAC address information.
Do they still use serial link in regular production
Personally, I'll tell you,
environment
I haven't seen that, but in the older days, we were using that in the 19th time. Nowadays, I haven't seen that.
Okay, I'm just curious.
Yeah, because serial link doesn't allow you the much speed, right? That's why. We have a Ethernet technology, man, 400 gig we have now, 400 gig, like the optic fiber we have. So no need to dependency on the serial team. Okay, guys, so that's all done. Okay, I have some plan. Let me pause the recording.